Alright guys, so in this second video here for lesson 5.5, it's the fundamental theorem of calculus. We are going to go over 4 examples that I have set up for us here. Kind of show how we evaluate these definite integrals using the theorem. So let's get to it. Let's see here. Our first example we have the definite integral of, and usually in the instruction it will say evaluate the definite integrals as opposed to, find the indefinite integral. So that the wording is going to be there in the instruction, so that way we know what to do for the problem. So because as of right now we have a lot of new notation, and it's very confusing when it comes to these integrals and what to do and how to do it and what formulas to use. So you might want to just take a note of, okay, what does it mean by definite integrals versus indefinite integrals. Anyway, so let's get to it. The first problem here, we have the definite integral from 0 to 4 of the function x to the third dx. So this asking, hey, what is the area under the curve of x cubed from 0 to 4? So that is the same thing as just, find the, the antiderivative and evaluate it at 4 and then subtract to 0. So that's our goal there, right? So let's get to it. Let's find the antiderivative of x to the third using, so if we use the reverse antiderivative rule of the power rule, we get x to the 3 plus 1 over the new power, which is 3 plus 1. Now we don't need to do the s plus c in this one, because when we subtract the difference of two endpoints, this plus c will cancel out. I'm just gonna go ahead and just do one example to show you guys, what happened to the plus c here. And then we want to evaluate this from 0 to 4. So let's go ahead and do that. All right, so we have x to the 4th and then 1/4 there plus c, evaluate that from 0 to 4. So I'm going to go ahead and show you two different ways of writing this. The first one, I'm going to write it how it is. I'm going to go ahead and evaluate the 4 into the x, so that's 4 to the 4th power plus c minus 1/4 times 0 to the 4th power plus c. Now notice that the plus c will cancel out, as you see. So 1/4 times 4 to the 4th power, that's going to be 1/4 times, so that's going to be 64, because we have just 4 to the 3rd left, plus c minus, this is going to be 0 in the middle, right here, that's going to be 0, and then plus c, distribute the negative sign, the c minus the c is going to be 0, so we're just going to end up with 64 there. Okay, so that's the answer for this. Another way, what you want to write this in terms of the work, so that way we don't have to write a lot of steps. What we can do here is, let's say or, okay, so we can write like this. Okay, we can say when we get to this part, we can say that this 1/4 constant is going to times to whatever the values that we evaluate inside the x. So we're going to have 1/4 times the endpoints, the larger endpoint before, so that's 4 to the 4th, subtract 0 to the 4th, and we can ignore the c there. So that's just going to give us 1/4 times 4 to the 4th minus 0. So the answer is still going to be 64. Okay, so same answer there. Okay, all right. So it's a little bit more lengthier than the previous lesson. The previous lesson, you would stop right here and that would be the answer. Now you go 3-4 more steps to get the answer. So a little more work. Okay. Moving on to part B. This is a little more work here. This asking for the definite integral of this function that has 3 different terms here. So we are going to use the properties of integral and integrate this individual term and then evaluate those terms from 1 to 3. Okay, so let's go ahead and do that. First, I'm going to go ahead and just find the antiderivative of each term. So we're looking at 4 times x squared divided by 2 minus 2 times e to the x is going to be the same thing, plus 5. You know what? I'm going to back it up just a little bit. I think I'm going too fast here. Let's go ahead and separate this into 3 separate integral here, so it's easy to follow. All right, so there it is. So those are 3 separate integral. We're going to integrate those guys. All right, So equals, so we have 4 times x squared over 2 for the first integral, minus 2 times e to the x for the second one, plus 5 times the antiderivative of 1 over x is going to be natural log of absolute value of x. So there it is. We have this as the antiderivative function of this here. And then now we're going to evaluate this antiderivative at the endpoints. So that's going to be from 1, 2, 3. Okay. All right. So now equal. The 4 divided by 2 is going to be 2. Okay. So what I'm going to do here, I'm going to write one long line here. Maybe I just need to skip some space here and use different color. I'm going to go ahead and do 2, because this is going to be 2 right there. 2 times 3 squared minus 2 times e squared plus 5 times natural log of 3. This is going to be all capital F. This is going to be capital F of b right there. Okay. Minus bracket 2 times 1 squared minus 2 times e to the first plus 5 times natural log of 1. Okay. So now this here, this is all capital F of a there, right? So that's what we're doing there. We're just using the fundamental theorem of calculus, and that's what it's saying here. To find the definite integral function from a to b, all we need to do first is find the antiderivative functions and then subtract the endpoints at those two of a and b there. Okay. So going back to this. Okay. So this is f of a minus f of b right there, right? Okay. You know, it can get a little messy. So you want to do as many as simple math you can before you plug into the calculator and get the answer. So right here, I'm gonna get 18 minus 2e to the third. I believe this is to the third plus 5 times natural log of 3 minus, we have 2 times 2e to the first plus natural log of 1 is going to be 0. So 5 times 0 is going to be just 0 there. Okay, and then 18, now simplify for the 18 minus 2 is going to be 16. These two guys are not like terms, so we're just going to just write them out like that. Plus 2e to the first plus 5 natural log of 3. Okay, and then now we're ready to plug this into our calculator and get the answer. I believe if you do this correctly, the answer should be around negative 13.24. Okay, all right. So there it is. That's the first 2 example. Okay, let's move on to 2 more example. And this next 2 example is gonna be harder just because the step that we find the antiderivative of these integrants involve us using substitution. So the initial step is harder because it's not easy to find the antiderivative. So expect these problems to be longer than this here. Okay, so let's get to it. All right. Part A, we're asking to find the definite integral from 0 to 1 of the function 1 over 2x plus 4. Now, we want to somehow get this integrand function into something like this. And then now we can use the antiderivative rule for 1 over u or 1 over x there. So our goal is to get to that form. So we want to let u be the function of 2x plus 4. Therefore, du is going to be 2 dx, okay? But we need to replace just dx here. There's no 2 there. So what we can do is we can solve for dx. So that's just 1/2 du is going to be dx. Just divide both sides by 2. Okay. So we have dx being 1/2 du, and then we have 2x plus 4 being u. So now we're ready to replace everything and then find the antiderivative. So now we have the integral of 1 over u times 1/2 du. We can factor out the 1/2, so we get 1/2 integral of 1 over u du. The antiderivative of 1 over u is going to be natural log of capital U. Okay, and now we can substitute what u is equal to. Okay, u was 2x plus 4. Okay, and now we want to evaluate this from 0 to 1. Okay, so let's do it. Okay. So this constant 1/2 here, we can leave that in the front of all the math that we're doing. So we're just going to plug in 0 and 1 into the function and then evaluate it. So we got natural log of absolute value 2 times 1 plus 4. Okay, close the absolute value, subtract the natural log of 2 times 0 plus 4, close bracket. Okay, so that will give us 1/2 bracket. This will give us 6 inside the absolute value, so we don't need the absolute value anymore because 6 is a positive number. Minus over here we have the natural log of 4. Okay, so I would accept this as the final answer. I don't mind. However, you can simplify this further, or if you prefer this to be in decimal, you can plug this into your calculator and get the answer. So I believe if you do this correctly, the answer would be around 0.203. Okay. All right. So as you see there, first we use U-substitution here, so that's the substitution method. All right, to get into this form here. Now in that form, we know what the antiderivative of 1 over u is. Okay, and then we just follow the step and apply the fundamental theorem of calculus. So again, this is our capital F of B, and this is the capital F of A. That's what we did there. Okay. All right. Moving on to the next example. Okay. All right. So the next example. Okay. Probably not straight at all. Draw a long straight line. Okay. All right. So next example, we have a radical function here. So it still looks like it's in the format of 1 over x, and then the antiderivative is natural log of u, but it's not quite the same because this case is 1 over square root. Okay. So when we do a U-substitution, we have to bring this back to the numerator with a rational exponent, so that way we can anti-differentiate this here. So let's start with our U-substitution being 6 minus t, not square root of 6 minus t, just 6 minus t. I think this is part of the hard step, is recognize what part to let our u function to be. Du is going to be -1 dt. Okay, but we need to replace dt, not negative dt. Okay, so dt is what we're looking at, just replace. So dt can be just written as minus du. Okay, just bring the negative to the other side, divide both sides by negative. So now dt now being replaced by negative du. Okay, and then u is this here. Okay, so let's do it. Let's go ahead and rewrite this as the integral of 1 over square root of u, because that's what 6 minus t is. Or dt is negative du. Now we can rewrite this as minus, because the negative can bring we can factor that negative to the front. And then let's rewrite this square root u as u to the negative 1/2 du. So now we're ready to, find the antiderivative of this. Okay. All right. So we have -1, that's what the negative is, times, well, what is the antiderivative of u to the negative 1/2? Well, we're going to add that by 1, divide by the new power. Okay. So let's figure out what that is. So we're going to have 2 in the front, because 1 divided by 1/2 is going to be 2, times u to the positive 1/2. Now we're ready to plug what u back into this here. So u now can be replaced by 6 minus t, and then 1/2 is going to be square root. And then now we're ready to evaluate this from 2 to 5. Okay. All right. Equals. Okay, so we're going to plug the phi into t and then 2 into t, and then subtract the difference. Similarly, I'm going to leave this 2 in the front. I'm going to draw one big bracket. I'm going to say, okay, let's plug in the phi first. So 6 minus phi, subtract square root, 6 minus 2, close bracket. Again, this is using the fundamental theorem of calculus. This is all capital F of B minus all capital F of A. So let's go ahead and do that. Okay, so 2 times square root of 6 minus 5, so that's going to be square root of 1, so it's going to be 1. 6 minus 2 is going to be 4, square root of 4 is going to be 2. Okay. And I think I'm making mistakes here. So if I backtrack this correctly, there's a mistake I made. this should be a negative right there. How does that become negative? Because when I did the math too fast earlier, negative 1/2 plus 1 is gonna be 1/2. Okay, and then this negative 1 divided by 1/2, that's going to give us negative 2. So this should be a negative 2, that should be negative 2, and now the answer is going to be 2. Okay. All right. So hopefully that makes a little more sense of what we do in this lesson here. So these are just a math example. We still got 1 or 2 more videos discussing the application example using definite integrals. So that will be the next video.